Howdy folks, congratulations on completing your first week of Chemistry 110. I usually do these week summary videos, or sometimes they're written announcements, and to kind of make sure we're all on the same page, we all arrived at the same conclusions, we know where we're going next. And there's usually an extra credit opportunity or two embedded within them, so they benefit you to watch in lots of ways. So getting started, I'm always up for a good meme. I like to laugh, so I don't trust atoms. I heard they make up everything. We're going to be talking about atoms in a lot more detail in the upcoming weeks. So highlights from week 1, you completed your Getting Started module. You did an introductory discussion and also your first week discussion, which I'm in the process of grading. You did reading, your Edpuzzle videos, took your first quiz, practice worksheets. We did the optional Zoom session, which was recorded and I have put up on Canvas, and then you've completed your first lab and selfie. So keep the questions coming. We're going to follow a really similar format to what we did this week, except the getting started stuff. So you're going to notice that there's like a pattern to, like, this is the reading, these are the Edpuzzles, this is how the discussion runs. So hopefully you'll start to feel a little bit more comfortable with the course and how things are going to go over the next couple weeks. So these were our learning outcomes. So the objectives from the weeks. This is the student will be able to at the end. And these are really going to be helpful for you in trying to understand what you need to know and how to prepare for quizzes and exams. There's content in the book sometimes, or in the Edpuzzle video, that you might sometimes wonder, like, am I supposed to know that? So this would be a really great place to check. It's also kind of nice to just know, what are we learning about this week? So these were our learning objectives from our first week, which was kind of coming down to the basics of what is chemistry, what will we be learning about in chemistry, along with a couple others. And one of the many places we explore those learning objectives is through our discussion. So I want to go over those discussion questions, and rather than have me tell you the answer, and some of them don't even have answers, they might be more opinion questions, I'm going to share with you some responses that I thought from your own responses, you folks, that I thought were especially good. I do not have students' names, but I will tell you what group they're from. In case you're, looking for yours. It's always, fun to have your teachers give you a shout out. So we're starting with why study chemistry. And I felt like there are a lot of great answers for this on why. So I just wanted to highlight a few. For this student that was in group 1, you can see there's a lot of detail there. And one I even like to highlight, the level of detail the student is displaying is really excellent. Remember, in your self-reply, you should expect to write 3 to 5 detailed sentences. That's your opportunity to really show me that you understand the content. I thought the student made a really great point about understanding even some safety things about our everyday life. For example, you should not mix bleach and ammonia. It's incredibly dangerous. So if you're, in cleaning the bathroom, mixing your cleaning supplies could be really bad, and chemistry can help you understand that. Some other great answers. I loved this. Improve your cooking talents, because I totally agree. My husband has taken up making his own bacon lately, which is delicious, among other things, but he's had to do some kind of basic chemistry lessons to understand some of the processes that he's looking into. So improving your cooking talents. And then I think this student made a really great point, these two from group 2, about just understanding your own health, improving your life with a basic foundation. Now, no one remembered this one, but it's the most important one. It's fun. I think chemistry is super fun, and I hope you enjoyed the quarter, and I hope you certainly agree with me by the end that why study chemistry? Because it's fun. So our next question that we looked at has to do with this. You might have seen this as a demonstration before, and I really enjoyed some of your guys' back and forth and hypotheses. Maybe one can is empty, maybe one can is full. Really getting at kind of a scientific process here and how we could test that. So I wanted to highlight a couple responses that were really great. This actually is a density related problem, which is I think where most of you ended up getting. The cans have the exact same volume, as the student from group 1 pointed out. They appear to have the same volume, so they take up the same amount of space. But we can tell from looking at them that they don't have the same density. The red can, the regular Coke can, clearly has a greater density because it's sinking. So if they have the same volume but not the same density, then the only thing left to consider is their mass, which the student points out. The material in the can on the left must have a lesser mass, than the other. And another student pointed out that we can deduce, we don't know its exact density, but we can deduce that this can must have a density lower than 1, and this can must have a density greater than 1, because the density of water is 1. And so we can use that to deduce an approximation to their density at least. And then another, this was also a group 1 student, a group 2 student actually kind of got to the heart of the issue in that it's the sweetener that causes that mass difference. The sweeteners, the kind of sugar substitute in the Diet Coke, does have a different mass than the sugar molecules are fairly large molecules, than the gargantuan sugar molecules in the Coke. And so that subtle difference in ingredients changes the density of the overall product. So kudos to you guys for that question. So this question took a really different turn than I had kind of intended it, but I just loved it. So the question is, describe a scientific, it's not even a question, actually, it's a statement. Describe a scientific discovery with which you're familiar with, and how was the scientific method demonstrated through this discovery? And instead, kind of what students did that I loved, and that's why I wanted to highlight it, was kind of talk about their own scientific process, like thinking about things. So the student is like, the scientific question that I want to know more about is about candles and wax, and where does it seem to go when it evaporates. And I feel like that's great because the beginning of the scientific method is really about making observations about the world around you and turning them into scientific questions. And then, of course, developing a process for answering that question. And so the student starts this off, and then we have, well, I wonder if it's a chemical or a physical change. So really relating it to our content, physical change because of melting, but like that's excellent, because if it's melting, it's a physical change. If there's no atomic rearrangement, then it's just a physical change. And another student, like, how does wax turn into nothing? So this is just great, an example of you guys engaging in the scientific process yourselves and being a scientific community. This is really great. How does wax turn into nothing? And so I went ahead, I thought I maybe knew the answer, but I went ahead and double checked because I wanted to share it with you, because I thought, like, oh, we can, since we don't have time necessarily to design an experiment to test it, we can maybe wrap up the scientific method in another way by finding out what's already known. And so I found this great site, How Candles Burn, and I highlighted kind of the most important elements. So there's aspects of both a physical change and a chemical change occurring. So the physical change is that the wax melts. The heat being produced by the flame melts the wax that's near the wick. And we're actually going to talk about capillary action later in the quarter, so maybe try to remember that the wick pulls some of that melted wax up into it, and it's actually the wax that's fueling the continuation of the fire. So that with a breakdown, wax is made out of hydrocarbons, meaning it's just carbon and hydrogens in the bonds, little tiny bit of oxygen. And so there's a chemical rearrangement. Those hydrocarbons and that little bit of oxygen turn into water and carbon dioxide. So the wax doesn't turn into nothing, because it can't, as that student pointed out, but it does seem to disappear because it leaves as water vapor and carbon dioxide. So that was a really great thing to see of you guys engaging in your own scientific communities here. So is fire matter? I absolutely love this question, and I love getting to see or listen to people kind of talk about it, because it's a little bit complex. We have this student from group 1, matter is anything that has mass and takes up space, therefore fire is not, because I don't think it has mass. Does it take up space? That's debatable. So you can see this student, and heat's produced, and we know that's energy, and energy is not matter. So really great argument for fire is not matter. But here is a really great argument also for fire being matter. Gases and chemicals take up space. So we have, that's also why I thought the flame would be considered matter, because of its components. So there's some gases, and gases take up space. I also like this student who's just like, I'm actually just more confused than when I started. Fire doesn't really have mass. but I think it does take up space and it emits both heat and light. And one of the things I wanted you guys to kind of think is, how could you prove this? How could you prove fire has mass or doesn't have mass? You know, if we put a candle on a balance and we light it, does that change what the balance says? Does it read more massive? Can you fill a balloon with fire, assuming that it couldn't melt? You know, could you prove that it takes up space? The answer to this question, it really gets into kind of even what this last student is saying, is like, it seems to have aspects of both. And that's really the answer. There are aspects of fire that are definitely matter, and there are aspects of fire that are not. The gases that are the thing that's being burned, and the gases that are produced from that are in fact matter. The heat and light being released, which is also an aspect of the fire, are not. So it's a little bit of both. Great job on that. It was fun to see your guys' thinking. Okay, so whoops. I also love this one. This is a good one for like, what is a physical change? What is a chemical change? And can you tell just by actually looking? Because I think it's not always really obvious. And so sometimes you need background knowledge to know if something is truly a physical or a chemical change. And for chemists, you have to prove it is. You have to test it to see if it's become a new substance. And so you guys kind of got into that a little bit. It's probably physical. I thought this was the student's initial post in group 2, and they compared it to cotton candy dissolving in your mouth. And that I love that. It's actually just spot on, and this is their follow-up. You can see how much their ability to explain has kind of grown. They've added a lot more detail. So there's an initial and a good follow-up. And that reference or that analogy they're using with the cotton candy is perfect, because that actually is exactly what is happening. Acetone is dissolving the cup. And dissolving is not a chemical change. It doesn't atomically rearrange the styrofoam. The styrofoam molecule is not broken down or made into something new. It dissolves into the acetone. But this definitely looks like, I could see someone being like, it's eating it. It's a chemical reaction, but it's actually just dissolving. And if we were able to run some tests on it, we could show that it's the same chemical compound that it was before. And the student really hit it on the head. It actually is just about letting the air out, the puffiness that causes it to appear the way it does. So what's next? So this week we got an introduction to what is matter. Now we're going to be exploring the foundations of matter, the building blocks of matter, elements, atoms, their classification. Then of course we're going to get then into the periodic table, which is where we put a lot of that information. So what's next for you? What do you need to be doing? So wrap up anything you have left over from week 1. Let me know if you need to use a life happens on something. Read through your week 2 checklist. You're going to be able to get to that by clicking on the checklist icon on our home page. I try to update that on Monday morning, so it will always take you to the most current checklist. You can also find it through the modules too. Make that initial post to your week 2 discussion early. Remember, you don't have to put a lot of detail into that. You don't have to do research in advance. It's just kind of your starting thoughts. Then, if you'd like some extra credit, send me a content-related Canvas message this week. So ask me a chemistry question. Give me something to do. I'm just sitting around here twiddling my thumbs. Not really, I have 4 kids. But and you can get 5 extra credit points, and these can make up for some of those Edpuzzle points that you lose along the way. And so this is one of the reasons I want to do that. And then, of course, have a great week. So ready, set, and go. I hope to see you guys later.